Hello, dear listeners. An autonomous flight operator has a number of tasks. They can be divided into preparation and direct execution. Preparation. 1. Drawing up an autonomous route, taking into account the terrain and technical features of the UAV. 2. Payload configuration. During the flight. 3. Control to monitor the telemetry, video, and drone deviations from the route. 4. Payload monitoring to turn on and aim the camera in time. 5. Intervention that you can take control at any time. All these skills need to be taught and practiced. And you can do this on our simulator. Why autonomous flight is needed and where it is used. Autonomous flight mode allows you to perform tasks accurately, without operator fatigue, and with minimal risk of error. That is why he is indispensable in the professional field. Autonomous flight mode is applied. Reconnaissance, a flight along a given route to inspect the territory, for example, an aircraft type of UAV. Aerial photography, a creation of orthophotoplans and 3D models of objects and terrain. Agro, survey of fields, vegetation maps, spot spraying. LiDAR, laser scanning to create digital terrain models. It is important to understand that many professional drones do not have manual controls at all. They only work autonomous. This applies to large multirotors, quadricopters for photo and surveying operations, as well as tall aircraft and hybrid UAVs. Let's look at the main types of autonomous flight that are used in UAVs and you can train in your classes. 1. Waypoint flight. The drone flies from point to point. At each individual flight point, you can set different parameters for the operation of the UAV. For example, start shooting, point the camera in a certain direction, hang for a while, etc. It is used in reconnaissance, overflight of the territory, for example, patrolling the boundaries of the site, flights between objects, inspection of communications. To linear flight along the object. Imagine a power transmission line for tens of kilometers and you need to inspect every pole. Autonomous flight along the line is an ideal solution. The drone flies parallel to the object, the camera looks away. The same applies to pipelines, roads, and canals. The drone examines an extended linear object. When creating a flight assignment, the length and width of the area required for study is adjusted. Let's consider a task where you need to survey a single object and capture it at different altitudes. Examples include creating a 3D model of a building, structural inspection, or bridge and tower assessment. The UAV must fly around the object from all sides. For this purpose, an automated orbital flight route is created. The drone flies in a circular path with the camera pointed toward the center. If necessary, the aircraft changes altitude to perform imaging and survey at various levels. As a result, a precise three-dimensional model can be obtained. For area survey, imagine a large field, a forested area, or a quarry. The task is to fly over and cover the entire area. For this purpose, a lawnmower pattern flight route is created. The drone flies back and forth, overlapping the imaging swath. The mission planning software, depending on the payload settings, helps automatically calculate the flight line spacing. This is the most complex type of route planning, yet one of the most in demand across many industries. It underpins aerial photography, agricultural operations using UAVs, and large-scale mapping. A separate category of autonomous flight is programmable flight. In this case, code is written in a programming language, and the UAV follows a specific route using sensors or computer vision, avoiding obstacles and interacting with other drones or robots. This also includes controlling multiple UAVs simultaneously, swarm drone control. All of this can be practiced and programmed using the special version of the simulator, Autonomous.